What are dimensionality reduction techniques? Dimensionality reduction techniques are methods used to reduce the number of variables in a dataset. While preserving as much important information as possible, these techniques are particularly useful in data analysis and machine learning. Now, there are two main reasons why dimensionality reduction techniques are used. One is to avoid the overfitting, and the second one is to improve the efficiency. Now, next are the dimensionality reduction techniques. So the number one is principal component analysis. It helps in reducing the dimensionality of data. In other words, it helps to identify a dataset's most important features or dimensions. Suppose you have a dataset with many different variables and you want to find the most important variables that explain the majority of the variance in the data. Now PCA helps to identify these variables by finding new artificial variables that are linear combinations of the original variables, and these new variables are called principal components. The first principal component captures the largest amount of variance in the data, and the second principal component captures the second largest amount of variance, and so on. Once you have identified the principal components, you can use them to reduce the dimensionality of your data. Now next one is t-distributed stochastic neighbor embedding. It is a machine learning technique that is often used to data visualization. It allows you to take high dimensional data and visualize it in a lower dimensional space. Now it works by first creating a probability distribution that represents the relationships between the data points in high dimensional space, and it then creates a similar probability distribution in the lower dimensional space, and it tries to minimize the difference between these two probability distributions by adjusting the position of the data points in a lower dimensional space. PCA preserves the overall variance in the data, ensuring that the most significant features are retained in the principal components, and the TSNE preserves the local structure of the data, meaning that points which are close together in the original high dimensional space will also be close together in the low dimensional embedding. Now this helps in visualizing clusters and patterns that exist in the data. Thank you.